3. Specific heat capacity. For the pure substance such as water, we would rather talk about its heat capacity per unit mass, and we call it specific heat capacity. It is the energy change of 1 kilogram of the substance per degree Celsius change in temperature. Therefore, specific heat capacity, small letter c, equals heat capacity, capital letter C, over mass m. So, Q equals mc delta T, or C equals Q over m delta T. Example 3. Energy liter to raise temperature. Without change in state, the energy transferred to an object increases its kinetic energy, so that its molecules vibrate more rapidly. Such increase in kinetic energy results in the increase of internal energy of the object. Experiment 2b. Measuring the specific heat capacity of water.
Fill 0.2 kg of cold water into a polystyrene cup and place an immersion heater and a thermometer in the cup. Record the initial temperature of water and the reading of the Joule meter. Switch on the heater. While heating the water, stir it continuously. When the temperature of water has risen by about 10 degrees Celsius, switch off the heater. Continue stirring the water and record the highest temperature reached. Record the final Joule meter reading.
When doing this experiment, you must totally immerse the heater in water and keep stirring throughout the experiment. Also, you should measure the highest temperature reached after the heater is turned off and take it as the final temperature of water. To further improve the accuracy of the experiment, you may start with cold water and heat it from 5 degrees Celsius below the room temperature to 5 degrees Celsius above the room temperature. In this way, the heat gained during the first half of the experiment may counterbalance the heat loss in the second half of the experiment. So the heat exchange with the surroundings may be much reduced. Example 4. Specific heat capacity of water. Refer to Part C. The heat loss to the surroundings and energy used to heat up the cup. The stirrer and the thermometer lead to a calculated specific heat capacity greater than the actual value. Experiment 2C. Measuring the specific heat capacity of aluminium. To measure the specific heat capacity of a good conductor such as a metal, the following setup is used.
Record the initial temperature of the block and the Joule meter reading. Then switch on the heater. When the temperature has risen by about 10 degrees Celsius, switch off the heater. Wait for a short while and record the highest temperature reached and the final Joule meter reading.
As metal is a good conductor of heat, heat conducts very well and ensures that the temperature is uniform inside the block. So no stirrer is necessary. Also note the other precautions of the experiment, including adding a few drops of oil in the holes to improve thermal conduction, and wrapping with cotton wool, and placing the block on a foam tile to reduce heat loss to the surroundings, and so on. In general, the specific heat capacity of metal is relatively low and that of water is rather high. Exam link 1. Finding specific heat capacity. Instead of calculating the specific heat capacity from a single measurement, we may measure the temperature rise when different amount of energy is supplied. The graph has a slope of delta T over delta Q, and hence the slope equals mc. We may calculate the specific heat capacity C by C equals slope over mass. For part B, heat loss to the surroundings is not acceptable as an answer since the block is well insulated. So you can only suggest there is heat loss to the container and the thermometer instead. Exam link 2. Temperature time graph. As heat is lost at the same rate, in other words, there is the same power loss. A larger mass has a larger heat capacity C, and that's for the same heat loss per second, which is power loss, delta Q over delta T equals C delta T over delta T. So a larger heat capacity C results in a smaller delta T over delta T, which is the temperature drop per second. Do check point 4 below.